You hear it at low speed first. That dry, high-pitched squeal when you roll up to a stop sign. Then maybe a little grinding that disappears if you press harder. And suddenly you're in that uncomfortable place where you don't know if you're being paranoid, or if you're one commute away from metal-on-metal damage. If you search for brake pad replacement on Toyota Corolla Cross, you're probably trying to answer a simple question: can I do this myself without turning a normal maintenance job into a brake nightmare? Because brakes are funny like that. 90% of the work feels straightforward, and then there's one hidden step, usually in the rear, that can waste your whole afternoon, trigger warning lights, or leave you with a pedal that feels wrong. So here's the real goal: not just swapping pads, but finishing the job with a firm pedal, quiet brakes, even wear, and no surprises on the first test drive. Before you touch a jack, confirm you actually need pads. Noise alone isn't proof. Some pads squeal because of dust, glazing, or cheap friction material. What matters is pad thickness and how evenly the pads are wearing. If you can see the pad through the wheel spokes, you're looking for the friction material, not the metal backing plate. If it's getting thin, or you see the wear indicator tab close to the rotor, that's your sign. If you're already hearing a harsh grinding that changes with braking pressure, stop driving and inspect immediately, because that's often the backing plate contacting the rotor. Now, the Corolla Cross is a normal, modern crossover in one important way: the front brakes are usually the easy part, and the rear brakes are where people get overconfident. The front caliper piston typically just presses straight back in. The rear may involve the parking brake mechanism, and depending on your exact setup, the piston might need to be rotated while compressing, or you may need to put an electronic parking brake into a service mode. I'm not going to pretend one universal trick covers every trim and year. Instead, I'll give you a decision path so you don't force anything and break something expensive. Let's talk tools and supplies in plain language. You need a safe way to lift and support the vehicle, a jack and jack stands rated for the weight, plus wheel chocks. You need basic hand tools to remove the wheel and caliper bolts. You need a way to retract the piston. For the front, a C-clamp or a brake piston compressor tool is usually enough. For some rear calipers, you need a windback tool that rotates the piston as it pushes in. You need brake cleaner, a wire brush or abrasive pad for cleaning the pad contact points, and the correct lubricant, a silicone-based brake grease meant for caliper pins and pad ears. Not general-purpose grease. Not oil. And please don't use anything that swells rubber boots. You also need a torque wrench. This is not the place to feel it tight. Wheels and caliper bolts are safety critical. If you don't have the exact torque specs in front of you, the right move is to look them up for your exact model and year in a service manual or a reliable database. I'll explain where torque matters most and how to avoid the common mistakes, but I'm not going to invent numbers. One more pre-check that saves mess: open the hood and look at the brake fluid reservoir. When you push caliper pistons back, the fluid level rises. If the reservoir is already near the max line, you can overflow it, and brake fluid eats paint. So you either remove a little fluid safely with a clean syringe or turkey baster dedicated to this job, or you monitor it closely while compressing pistons. Keep the cap loosely on top to prevent splashes but allow pressure equalization. And never let dirt fall into the reservoir. Safety setup matters more than people admit. Park on a flat surface. Set the parking brake if you're doing the front first, and chock the rear wheels. If you're doing the rear brakes, you may need the parking brake released at some point, so you'll chock the front wheels and make absolutely sure the vehicle cannot roll. Break the lug nuts loose before lifting. Lift at the proper jack points and support with stands. Give the car a firm shake before you put any part of your body near the wheel well. If it feels sketchy, it is sketchy. Alright. Front brakes. With the wheel off, take a second and just look. You're checking for obvious leaks around the caliper, torn dust boots, and uneven pad wear. Uneven wear is a clue. If the inner pad is much thinner than the outer, the slide pins may be sticking. If one side is worn more than the other, you might have a caliper issue. Pads alone won't fix that. Turn the steering wheel to give yourself room. Locate the caliper and the caliper bracket. Most setups have two caliper slide pin bolts holding the caliper to the bracket. You remove those, then the caliper can pivot up or come off. Support the caliper so it doesn't hang by the brake hose. A bungee cord or hook works. Hanging by the hose is how you create a future brake hose failure. Pull the old pads out. Pay attention to how the hardware sits, the anti-rattle clips, any shims, and any wear indicator tabs. If your new pads come with new hardware, use it. Old clips can be rusted or lose tension, and that's a direct path to squeaks and clunks. If your pads don't include hardware, inspect the existing clips carefully. If they're heavily corroded, replace them anyway. Now the part that separates a quiet brake job from a noisy one, cleaning the pad abutment areas. The pads slide in the bracket on those stainless clips. Rust builds underneath and squeezes the clip inward, so the pad can't retract properly. That causes dragging, heat, and uneven wear. So you remove the clips, clean the bracket lens down to smooth metal, and reinstall clips so the pads can move freely. Don't go crazy removing metal, just remove rust and scale. Then test fit the pad ears in the clips. They should slide with light hand pressure, not hammering, not binding. Slide pins next. Pull the pins out one at a time, wipe them clean, inspect for pitting or corrosion, and check the rubber boots. If a boot is torn, water gets in and the pin seizes. Apply a thin, even coat of proper brake grease to the pin and reinstall. Too much grease can hydraulic lock the boot and prevent full movement, so thin is good. Make sure the pins move smoothly. Rotor check. You're not doing a full brake overhaul here, but you should look at the rotor surface. Light grooves are normal. Deep scoring, cracks, heavy rust ridges, or a rotor that looks blue from heat are red flags. If the rotor is badly worn or below minimum thickness, pads alone won't give you good results. Also spin the rotor by hand and listen. A slight scrape is normal with pads removed, but grinding or roughness could be something else. Now retract the front piston. This is where people create the first big mistake. They clamp the piston back fast, the fluid overflows, and they don't notice until the paint is damaged. Go slow. Use an old pad against the piston face to spread the force evenly, then compress with a C-clamp or piston tool. Watch the reservoir level as you go. If the piston doesn't want to move with steady pressure, stop. Don't force it. A stuck piston can indicate corrosion or a seized caliper, and forcing it can tear seals. Before installing new pads, keep friction surfaces clean. No grease on the pad material. No grease on the rotor. If you touch the rotor with greasy hands, clean it with brake cleaner. Lubrication goes only on the correct contact points, a tiny amount where the pad ears contact the clips, and sometimes on the back of the pad where it contacts the caliper piston or bracket, depending on pad design and whether shims are used. Many modern pads come with shims or coatings that don't need extra goop. More grease is not better. Grease in the wrong place can reduce braking and attract grit. Install the new pads in the bracket. Reinstall the caliper over them. If it doesn't fit, the piston isn't fully retracted or the pads are not seated correctly in the clips. Don't pry the caliper on. That's how boots get torn and pads get jammed. Then tighten the caliper slide pin bolts to the correct torque. If the caliper bracket had to come off for any reason, those bracket bolts are even more critical. Again, use the correct spec for your exact vehicle. Wheel goes back on, lug nuts snugged in a star pattern, then final torque with the vehicle on the ground. If you torque wheels in the air, you can get a false reading and the wheel can shift when it's lowered. Now, the rear brakes, the part that makes people think they did everything right until the car tells them they didn't. This is where brake pad replacement on Toyota Corolla Cross can be either a normal DIY afternoon or a frustrating lesson in modern parking brake systems. The key is identifying what you have before you try to push the piston back. Look at the rear caliper. If you see an electric motor assembly on the caliper, or a wiring connector going directly into a parking brake actuator, you likely have an electronic parking brake. In that case, the system may need to be put into a service mode so the motor retracts properly. If you try to force the piston without retracting the electronic mechanism, you can damage the actuator or set faults. Some vehicles allow service mode through a scan tool, some have a manual procedure using the ignition and parking brake switch. The safest advice is, consult the procedure for your exact Corolla Cross configuration. If you don't have a scan tool and you can't confirm the manual service mode steps, that's a good moment to pause and consider professional help, because the cost of guessing can exceed the cost of the brake job. If you do not have an electronic motor on the caliper, you may have a mechanical parking brake integrated into the caliper. Many of those require the piston to be rotated while being pushed in. You can often recognize this by looking at the piston face. If it has notches or a pattern designed to engage a windback tool, that's your clue. A plain, smooth piston face often indicates a straight push-in type, but don't rely on that alone. The notches are a strong hint. Rear pad removal is similar to the front. Remove the caliper slide bolts, support the caliper, remove pads and hardware, clean the bracket lens, inspect and lubricate slide pins. The difference is piston retraction. If the piston needs to rotate, you use a windback tool that both turns and presses. You turn it slowly, keeping it square so you don't cock the piston in the bore. If it binds, stop and reassess. Forcing it can damage the internal mechanism. Also pay attention to piston orientation when you're done. Some designs require the piston notches to align with the pin or tab on the inner pad. If the notch isn't aligned, the pad won't sit correctly and you'll get uneven pressure or noise. Another rear-specific pitfall is the parking brake itself. If you're working on a mechanical parking brake setup, make sure it's fully released before you try to retract the piston. If it's partially engaged, you'll fight the mechanism and think the caliper is seized. And after you're done, you may need to operate the parking brake a few times to let it self-adjust. With electronic parking brakes, the system may run an adjustment routine automatically, or it may need a specific sequence. Again, follow the correct procedure for your setup. As you reassemble the rear, be extra careful with boots and clips. Rear brakes often see more corrosion because of road spray, and sticky rear pads can overheat quickly without you noticing. After everything is bolted up and torqued, spin the rear rotor by hand before the wheel goes on. You're not looking for a perfectly free spin, pads can lightly drag, but you are looking for obvious binding. If it's hard to turn, something is wrong, pads jammed in rusty clips, piston not fully retracted, parking brake not released, or a seized slide pin. Now comes the moment that causes the scariest first stop stories, the pedal. When you push the pistons back, you create extra clearance between pads and rotors. The first few pedal presses move the pistons out to take up that gap. If you start the car and drop it into gear without pumping the pedal, your first brake press can go much farther than expected. So before you move the vehicle, with the engine off, press the brake pedal slowly several times until it becomes firm. Then start the engine and confirm the pedal feels normal with vacuum assist. If it sinks excessively or feels spongy, stop. That can indicate air in the system, a leak, or a caliper issue. Pad replacement alone shouldn't introduce air unless something went wrong, but you don't ignore a weird pedal. Check the brake fluid level again. Top up only with the correct fluid type specified for the vehicle, and only if needed. Don't overfill. Clean any spilled fluid immediately. Now bedding in. New pads need a controlled break-in to transfer an even layer of material to the rotor and stabilize friction. If you skip this, you can get noise, uneven braking, or a grabby feel. Bedding procedures vary by pad type, but the general idea is a series of moderate stops from a safe speed, allowing some cooling between them, without coming to a complete stop and holding the pedal hard while the brakes are hot. Holding the pedal at a stop can imprint pad material and create a vibration later that feels like warped rotors. Use common sense, do it in a safe area, and if your pad manufacturer provides a specific bedding procedure, follow that. During the first drive, listen and feel. A light smell is normal as coatings burn off. Some mild noise can happen as things seat. But loud grinding, a strong pull to one side, a steering wheel shake under braking, or a burning smell that doesn't fade are red flags. If the car pulls, you may have a sticking caliper, contaminated pad, or uneven pad movement. If you hear a clunk, a clip may be installed wrong or a bolt may be loose. If you get a warning light related to the parking brake or stability systems after rear work, don't keep driving and hope it clears. Scan for codes and verify the parking brake service mode and calibration steps were done correctly. One more subtle point, brake noise is often blamed on the pad compound, but a lot of it is installation detail. Pads that can't slide freely will squeal. Missing or reused hardware that's lost tension will rattle. Grease on the wrong surface will glaze and squeak. An over-torqued or under-torqued fasteners can create vibrations that sound like bad pads even when the pads are fine. If you want a mental checklist to keep you honest, think in terms of movement and cleanliness. The pads must be able to move in the bracket. The caliper must be able to move on the slide pins. The piston must retract and extend smoothly. And the friction surfaces must stay clean and dry. That's the difference between swapping parts and actually completing brake pad replacement on Toyota Corolla Cross like a pro. You're not just installing new pads, you're restoring the system's ability to apply and release evenly. And if at any point you hit one of these moments, piston won't retract with steady pressure, slide pins are seized, boots are torn, rotor is deeply scored, or the rear parking brake system doesn't match what you expected, stopping is not failure. It's the smart move. Brakes don't reward stubbornness. Do it patiently, keep everything clean, torque what matters, and treat the rear brakes like their own system instead of a copy of the front. When you finish and the pedal is firm, the car stops straight, and the brakes are quiet, you'll know you didn't just save money. You avoided the one hidden step that turns a simple job into a dangerous one.